Magnetic effects of current. Lecture number 2. So, coming to the introductory part of this lecture. In this lecture, we'll be dealing less of magnetism and more of electricity. But to list out, we'll be dealing with the other applications of magnetism, the concept of torque, the concept of flux, and we'll be discussing about some general domestic circuits. Okay, so let's proceed with the first topic, which is the applications of magnetism in other fields. So, applications of magnetism. This principle is basically used in transformers, okay, and machines like DC machines, synchronous machine, etc. And in the field of medicine, it is used in MRI, which is magnetic resonance imaging, echo scans, and CT scans. But to have a better understanding of these applications, whatever it may be, like transformers application or the application of magnetism in the field of medicine. So, to have a better understanding of these, we need to first learn about the concept of flux and something about torque. These are actually truly physics concepts, okay? So, let's start with the concept of flux. So, as defined in lecture number 1, okay, as defined in lecture number 1, the flux is the product or the dot product of the magnetic field and the desired cross-sectional area of the conductor. So mathematically, phi is equal to B into A. Note that the flux is an imaginary quantity. Fine. So to have a better idea, I'll be showing to you a demo in which you have a rectangular loop carrying the current. So this is my B bar, the magnetic field, and this red arrow shows the area vector. So the direction of the flux will be given by the pink line. Okay. So note that the direction of flux is along the direction of the magnetic field, and the direction of the area vector. Okay. Now, let's move on to the concept of torque. Note that the torque is a physical quantity which is a cause for rotation. So if at all any body is rotating, then there is a torque in presence. So physically and mathematically, the torque tau is defined as a product of the force and the radial distance. So tau equal to R cross F. And the direction of torque is always perpendicular to both the direction of F and direction of R. So given below is an example to find the direction of torque. So here we can use the right hand rule in this case, actually in any case. First, you have to point your four fingers of the right hand along the direction of R bar. Okay. Then curl these four fingers along the direction of F. So now the direction of the thumb will be the direction of the torque, which is upward here. Fine. Now based on these concepts, let's learn how these motors and generators work. So given below is the diagram. Please go through the text given below. In this case, the torque is responsible for the motion, and here the direction of the arrow shown below is the direction of the torque, Here your thumb points in the direction of the arrow. Okay. Now let's move on to a special topic, which is a special electrical instruments. So here we'll be starting with an instrument called as a galvanometer. A galvanometer is an instrument that can detect the presence of current. Okay, the pointer remains at zero and it deflects either way if at all the instruments detect any current. So given below is a diagram of how the galvanometer looks. Okay, now let's move on to our second instrument, which is called as the ammeter. So an ammeter is an instrument that can measure the amount of current in a circuit. The pointer remains at zero for zero current, okay, and it can deflect either to the right or left of the zero mark depending on the direction and the magnitude of current. Given below is a diagram of the same ammeter. Please have a look. Now let's move on to a third instrument called the voltmeter. So voltmeter is an instrument to measure the amount of voltage. Here again you have a pointer which remains at zero for zero voltage, and the pointer reflects either to the left or right depending on the polarity and the magnitude of voltage. Given below is a diagram of how the voltmeter looks. Okay. Now let's move on to our fourth instrument called as the wattmeter. So wattmeter is an instrument that can measure the amount of power consumed by a circuit. Here also the pointer remains at zero for a zero voltage across the two ends of the terminals. It can it can deflect to the right of the zero mark depending on the magnitude of power. Given below is the diagram of the wattmeter. Now let's move on to a new topic called as the domestic electrical circuits. So in a domestic circuit, we use many electrical components such as the resistor, a capacitor, an inductor, a diode, an amplifier, a transistor, and etc. There are many more, but these are the most familiar ones. Okay, so let's start with describing each of these components. So let's start with the resistor. So a resistor is an electrical component which provides resistance to the electrical circuit. It is denoted by the capital alphabet R and its units is ohms. And this is how the resistor looks. Okay. Now let me introduce to you a new device or a new component known as a capacitor. It is a component which provides capacitance to the electrical circuit. It is denoted by the capital letter C and the units are farads, F. And this is how the capacitor looks. Okay. Now let me show to you the inductor. This is the electrical component which provides inductance to an electrical circuit. It is denoted by L and the units of L are Henry given by H. And this is how an inductor looks. The next component would be the diode. I repeat, the diode. It is an electrical component which provides preferential voltage and resistance to any electrical circuit. It is denoted by D and it has units V and or ohms depending on the type of the diode. This is how a basic diode looks. So the next one is a transistor. It is an electrical component which provides preferential voltage and current to to any electrical circuit, denoted by capital T, and the units are V and or I, actually A. So given below is a symbol of the transistor. It is a three-terminal device. Okay. So the last component which I'll be teaching to you today is the amplifier. It is an electrical component which amplifies the voltage of any electrical circuit. It is denoted by A. The units are voltage. Okay. And this is how the amplifier looks. So usually in general, any domestical electrical circuit consists of any sort of the given electrical components. And some of the common electrical circuits are shown below. Please have a look patiently. This is just for illustrative purpose. You need not understand all this, okay? Similarly, we have much more complicated circuits. Under this category, other complicated circuits. So, this one is a circuit for an electronic siren. This one is a circuit for the headlight of an automobile. So similarly, these are other electrical circuits which are highly complicated. So this is basically to tell you that any type of circuit can be made out of these electrical components. That's it. So this is the end of the lecture. Thank you for watching. Good luck. Bye.